In this chapter, we're going to explore the critical and, often vulnerable world of web authentication. Now, on the surface, it seems pretty simple, right? A user types in a username and password, and the application lets them in. But this basic mechanism, this digital front door to almost every online service we use, is actually the main battleground for a ton of major security vulnerabilities.
So, here's our game plan. First, we'll establish why authentication is so incredibly important. Then, we're going to walk through an attacker's playbook, starting with the most direct attack, the brute force assault. After that, we'll dig into more subtle tactics, like finding clues in information leaks and even twisting the application's own logic against itself. And finally, we'll switch gears and talk about defense, how to build a secure fortress to protect against all of this.
A really good way to think about authentication is like the main entrance to a secure building. If an attacker can just walk through that front door, it doesn't really matter how strong the locks are on the individual offices inside, does it? Authentication is that first and most critical line of defense. If it fails, all the other security layers, like session management and access controls, they just become useless.
And this isn't just some abstract theory. Security experts consistently find that even though it's so important, authentication is very often the weakest link in the chain. It's kind of shocking, but a huge number of major applications have been completely compromised because of some pretty simple flaws in how they handle logins.
So, to be super clear, authentication is simply the process of verifying that you are who you say you are. And in the vast majority of web apps, we're talking over 90%, this is done with a standard HTML form, where you pop in a username and password. It's something we all do every day, but that familiarity can hide some really significant risks just beneath the surface.
All right, let's get into the first play in an attacker's playbook, the brute force assault. This is basically the digital version of trying every single key on a keychain until one of them finally opens the lock. It's not subtle, not at all, but it can be incredibly effective against applications that don't have the right defenses in place.
The very first weakness an attacker is going to look for is a weak password policy. And as you can see here, with this example of a 4-character minimum, these are surprisingly common. See, when a system lets users create short, simple, or even blank passwords, human nature kicks in, and people will absolutely take the easy route. And that just makes an attacker's job exponentially easier.
And what's really fascinating here is what this tells us about human predictability. When you analyze data from real-world security breaches, you see the exact same weak passwords showing up over and over again. This means an attacker doesn't have to guess randomly. They can just use a list of the most common passwords, which dramatically increases their chances of getting in. Now, trying all these passwords by hand would take forever. So what happens when an attacker uses the power of a computer to automate this whole guessing game?
Well, this is what happens. Automated tools, like the one you see here, can fire off thousands of login attempts every single minute. And this example shows exactly how a successful guess is spotted. Notice how the server's response for the correct password, password 2, has a totally different status code and content length? The tool is built to see that little anomaly instantly, turning a slow manual guessing game into a lightning-fast automated attack.
Okay, so now we're going to look at a more sophisticated technique. Instead of just guessing blindly, a smart attacker will actually listen to the application's responses for little clues it might be giving away by accident. This whole approach is about exploiting information leaks.
This slide shows a classic, and I mean classic, example of an information leak. Just look at the two different scenarios here. On the left, a valid username with the wrong password gives one error message. But on the right, an invalid username gives a completely different message. This tiny difference is a huge vulnerability. It lets an attacker do something called username enumeration. Basically, they can build a whole list of valid user accounts just by trying different usernames and seeing which error message they get back.
But these information leaks can be even sneakier than different error messages. Sometimes the messages on the screen look exactly the same, but there are tiny differences hidden in the HTML source code, like a stray comment or an extra space. Tools like the compare you see here are designed to automatically spot and highlight these tiny variations, giving an attacker that same ability to figure out valid usernames.
And then there's one of the biggest and, frankly, most easily preventable leaks, sending credentials over an unencrypted channel. If a website uses HTTP for its login form, anyone on the same network, someone at the same coffee shop, a compromised router, can just read the username and password in plain text. It's like sending a postcard. HTTPS, on the other hand, encrypts all that traffic,
making it an absolute must-have for secure authentication.
So now we're getting into a more advanced kind of attack, subverting the application's own logic. Here, the target isn't the main login form itself. Instead, it's all the other features built around it, things like the forgot password flow or the remember me function. And a lot of the time, these secondary features are where the real vulnerabilities are hiding.
The key thing to understand here is that account recovery functions are often built with much weaker security than the main login. Take a look at this example. A security question like, "What street did you live on?" is often information someone could find online with a little bit of research. So these features, which are meant to be helpful, can accidentally create a backdoor for an attacker.
Another common target is that remember me functionality. In this example, you can see a cookie that's storing the username right there in plain text. What this means is the application is trusting data that comes from the client side, from the user's own browser, to handle authentication. And that is a huge design flaw. A core principle of security is you can never implicitly trust data that the user can control.
This question really gets to the heart of the problem. I mean, if the application blindly trusts what's in this cookie, what's stopping an attacker from just changing its value to admin or any other privileged user? In a lot of poorly designed systems, the answer is nothing. And just like that, an attacker could get full access to someone else's account without ever needing their password.
Okay, so we've spent a lot of time looking at how an attacker can break down authentication. Now, let's flip the script and focus on defense. How do we build a secure authentication fortress? Well, it's all about taking the lessons we've learned from these attacks and using them to design systems that are resilient from the ground up.
To stop brute force attacks, you really need a layered defense. The first layer is to implement account lockouts. So after a few failed attempts, say 3 to 5, the account gets temporarily suspended. This just kills the speed of an automated attack. But here's a crucial detail. The application should never tell the user that the account is locked, because that would just confirm that the username is valid. The final layer is to use challenges that are specifically designed to stop bots. And that brings us to a mechanism we've all seen before, the CAPTCHA. Its entire job is to present a little puzzle that's super easy for a human to solve, but really hard for a computer. This is what effectively slams the door on those automated tools that make high-speed brute force attacks possible in the first place.
So, to wrap up our defensive strategy, let's run through a checklist of core principles. First, enforce strong password rules. Use a single generic failure message like invalid credentials to prevent username enumeration. Always use HTTPS. Never store passwords in plain text. Use a strong, salted hashing algorithm. Design your account recovery to be just as secure as your main login. And finally, log everything so you can actually detect when an attack is happening.
And this all leads us to the main takeaway of this entire chapter. Secure authentication isn't about one single perfect feature. It's a system. It's a whole series of carefully designed layered defenses where every single piece is built with an attacker's mindset, trying to anticipate and shut down every possible angle of attack.
So, I'll leave you with a final thought. Now that you understand the attacker's playbook, from brute force all the way to twisting an application's logic, you're much better equipped to look at your own digital world. Think about the services you use every day. Think about the systems you might build, and ask yourself, is that digital front door truly secure?